Hello my pre-calculus student. In this video we are going to graph the transformation y equal a sine of bx plus c plus d of the parent function y equals sine of x. The order to graph the transformation of y equal a sine of bx plus c plus d, that we have to begin with the midline first, which is y equal d first, then the amplitude, which is the absolute value of 8, and then the period, which is 2 pi divided by the absolute value of b, and lastly will be the phase shift, which is the negative c divided by the absolute value of b. So let's begin with the example. Graph the function y equal 4 sine of x. Now if you look at this function, you can see right away that your b is 1, your c is 0, and your d is 0. If you cannot see it, you can rewrite it. If I rewrite for you, it will be y equal 4 times sine of 1x plus 0 plus 0. So your d is 0. So since d is 0, we can begin with the graph right now. So let's see, 1, 2, 3, 4, 5. So I start with my x-axis, and then my y-axis. So I can make a note right here that my midline is y equal d, and my d is 0, so y equals 0. So the line y equals 0 will be my x-axis. Next step, I'm going to find the amplitude. So amplitude is the absolute value of a. So in this case, the absolute value of 4. So that will be equal 4. So it means that I'm going to draw the two lines, one above the midline and one below the midline. So how can I draw that two lines? I'm going to begin with the absolute value. So from I will begin with the amplitude. So for my midline, go up 4 units. 1, 2, 3, 4. So I'm going to draw. So this will be my y maximum 4. And from my midline, I will count 4 units down. So 1, 2, 3, 4. So again, these are my amplitude. So therefore, this will be the y maximum, and this is the y minimum. So first you locate the midline, and then next you want to find the amplitude. And from your midline, after you got your amplitude, then from your midline you go up 4 units, and then draw a line, and that will be your. And again, you draw a horizontal line, so that will be your y maximum line. And then from your midline, you will go down 4 units and draw another horizontal line. That will be your y minimum line. So now your graph will have to be oscillate between your y maximum and your y minimum. Next step, we are going to find the periods. May I move the paper up a little bit so that we can see? Oh, sorry. Okay. Now we need to find the periods. So periods, the formula 2 pi divided by the absolute. Now 2 pi is the same thing as 360 degrees. If you want to deal with degree, in this case I'm going to deal with gradient. So 2 pi divided by the absolute value of b, but your b is 1, so 2 pi divided by the absolute value of 1. So basically it's just 2 pi. So the period is 2 pi. So it means that think about the set of five points for the sine graph will take you 2 pi, which is the length of each set of five points for the sine graph, and it repeats itself again. So in case if you do not remember the definition of periods, I'm going to write it right here for you again. Periods is the distance between any two sets of repeating points. So for the sine function, each set will have 5 points. So for every 5 points, that length, that distance will be 2 pi. So I'm going to go to my midline. Then I'm going to label from 0 and then 2 pi. Okay. So I'm just going to go ahead and 0 and then 2 pi. Next, I'm going to have to divide the periods into 4 equal intervals. So make a note right here. Divide the periods into 4 equal intervals. Why we have to divide into 4? Because you remember you want to get a set of 5 points. So therefore this is into half, so this is pi. And now cut half into 4, so now you have half of a pi and 1/2 of the pi, so 3 pi over 2. So now we divide into 4 equal intervals. And now you just need to graph the graph of sine. So now remember the graph of sine. You can evaluate this. If you don't remember how the graph of sine looks like, then I'm just go ahead and evaluate for you so you can see it. Evaluate the function y equal 4 sine of x for x equals 0, pi over 2 pi, 3 pi over 2, and then 2 pi. So it means that if you remember the pattern for the sine function, the set of 5 points, the period is 2 pi, and then the set of 5 points will be like this. Your midline is the x-axis, and your y maximum is 1, your y minimum is -1. So you plus your number of points y equals 0, y equals 1, y equals 0, y equals -1, and y equals 0. So this will be your set of 5 points. So right now so this will be the graph of the parent function y equals sine of x. So the amplitude for the parent function is 1. So amplitude is absolute of 1, which is 1. So but the amplitude for our given transformation is 4. So now you see your y maximum and your y minimum is not going to be 1 no more. It will be 4 for y maximum and -4 for y minimum. And if you want to make sure, you can go ahead and make a table, and you can plot the points. You can go ahead and evaluate using your table So I'm going to put x. This is y equal 4 sine of x. So x equals 0. Y, so 4 times sine of 0, just 0, so just 0. So you can see that the first point will be stay the same right here, 0, 0. But if x is pi over 2, sine of pi over 2 is 1, or sine of 90 degrees is 1. So now 4 times 1 will be 4. So the point will be, go to the y maximum with 4. And then if x equal pi, so you can see that the point, the set of 5 points will be very similar to the set of 5 points from our parent sine function, except the amplitude is 4, so it will be vertical stretch. So your y max will be 4, your y min will be negative 4. So for sine, let's move on to pi sine of pi 0. So 4 times 0 is be 0. And then 3 pi over 2. 3 pi over 2. So sine of 3 pi over 2 will be 1. So now it will be 4 times 1 will be 4. And then 2 pi. Sine of 2 pi will be 0. So 4 times 0 is just still 0. So now the next step you're going to do is that you are going to connect the 5 points using curve. So I have 4 points, and the last point will be 2 pi comma 0. So this will be one graph, or one complete rotation. And then you just repeat the graph itself. So it means the next, so I'm going to highlight it. So this will be one complete rotation. And if we want to continue, or if you want to repeat this 5 sets of points again, you just divide into 4. 1, 2, 3, 4. So 2 pi plus another 2 pi be 4 pi. And so again, the period will be 2 pi. So the distance for the set of 5 points. And you just repeat the point again. So from 0, go to the maximum, 0, minimum, and then 0. And then connect the 5 points using curve. And then you can go to your negative angle or negative input. So again, we have 1, 2, 3, 4 should be negative 2 pi. And again, our set of point will be start with 0 max, 0 mean, 0. So it's the 0 max, 0 mean, 0. And connect this set of 5 points with a curve. So the set of 5 points just repeats itself. So from now you can see the pattern will be 0, y equals 0, y equal the maximum, y equals 0, y equal the minimum, y equal 0. So I can make a note right here that the pattern will be 0 max, 0 mean, I'm so sorry, this is mean, and then 0. So what we did last step was that so after we graph one period, and then lastly we graph additional periods. So again, we're using the set of 5 points. So we have y equals 0, y equals max, y equals 0, y equals mean, and y equals 0. So let me do the second example with you, and this time we will do a little bit faster because now we kind of see how the pattern of the sine graph looks like. So this time we will go much faster. So let's do example 2. Okay, so let's graph the function y equal 3 sine of 2x. So again, you can write this function as y equal 3 sine of 2x plus 0 plus 0. So you will start with your midpoint, your midline first. So the midline, which is right here, D. So the midline be y equals 0. Next, you will, so you know your B, so you start with the periods. Should be 2 pi divided by the absolute of B, which is absolute value of 2. So therefore, just 2 pi divided by 2. Simplify, so the period is pi. And then you divide the periods into 4 equal intervals. Into 4 equals parts. You want to say parts, that would be okay. And then so therefore it will be pi, so each part will be pi over 4. So each one of the tick marks on the graphs, and then I start with the graph now. So this will be our midline. So label, this will be the midline. So this will be the line y equals 0. And then we'll draw the y-axis. And then the amplitude. So from here, be able to know our amplitude from the given function. We'll be able to see that the amplitude is the absolute value of 3. So this is just 3. So it means that from my midline, I'm going to go ahead and draw 2 lines. So one will be above and one will be below with 3 units above the midline. So 1, 2, 3. So here we are, 3 units above and 3 units below the midline. So 3, -3. And since we know the pattern of the sine function is first I'm going to start with the midline first. I make sure I label my periods is so let's graph 2 periods. The periods is pi. So divide that into 4 equal. So each one of the parts will be pi over 4. And again, so this will be the first period, and this will be the second period. So pi over 4, 2 pi over 4. I don't have enough space, I'm going to put it here. 2 pi over 4. And then 3 pi over 4. Then you must follow the pattern for the sine function. It will be 0 maximum at pi over 4, 0 at 2 pi over 4, minimum where when x is 3 pi over 4, and then 0 at pi. And now you are going to connect the 5 point using a curve. So this would be one complete cycle. So this will be one period of the graph. And then you just repeat the same pattern again. So now we will have, and again divide my second period into 4, and then from 0 maximum, 0 minimum, and then 0, and then we connect my 5 points. So this will be two periods of the graph. And then you can graph the third one. You just go to the left hand side and when you graph negative, again the period is pi, so we'll label this will be negative pi. So this will be one period, and then we divide it into 4 equal, again period is always absolute value because that's the distance, so then there'll be no negative distance. And you repeat the same process again. You start with your pattern y equals 0, y equals maximum, y equals 0, y equals minimum, and then y equals 0. Now if you can label one tick mark. So this will be, this is negative pi over 4. Okay, and then you connect the 5 point using the curve again. You can see that after we graph 3 periods, you can see that the set of 5 points just keep repeat itself. Okay, so let's write out the summary for this video. So summary. In this video, we learned this to graph the transformation, y equal a sine of bx plus c plus d, where c equals 0 and d equals 0. And we learned that the midline is y equal d. The amplitude is the absolute of h. The period is 2 pi divided by the absolute value of b. And in this video, we didn't talk about the phase shift, so I'm just go ahead and stop here. We didn't talk about the phase shift at all. So maybe in next video we will work on example with the phase shift. Thank you so much for watching this video. You have a good day. See you in class. Goodbye.